Hello guys, welcome back to my channel, Coach Shiba, and today I'll be posting this video after a long time. Okay, so this is Code Shiba, and I'll be posting video after a long time because something was happening in my college and I had to do it. I had to give my full attention towards it, so I wasn't able to make videos. Uh, that's it for now. And the thing which I'm trying to do today is this is another challenge that I'll be taking up. The series which in which I continued posting regularly. I did it for like 20 days of continuous coding, and after 20 days I dropped it. So instead of having a really big goal like that for coding continuously for, let's say, 50 days or 100 days, what I'm trying to do is I'll be taking on smaller and smaller milestones, and this is the first playlist for linked list. And what I'll be doing is, uh, in this challenge, I'll be posting linked list problems and solutions every day, and today is day one of doing so. Okay, so this is actually my revision series. All I'm doing is revising everything that I've already learned. So if you think that like I'm figuring out everything by myself, that is not entirely true, but up to an extent it is true, because yes, I am thinking live. I intend to have very less cuts within my video, because yes, first of all, I don't like to edit my videos too much, and this is for my memories. These are for the time, if I ever do something good in my life, I'll be looking back and I'll be saying, yes, I used to do that. So this is like one of those personal uh, projects for me. Okay, so in this day one for linked list, today we'll be learning about linked list implementation in C++. Okay, so what doing throughout this video is, first of all, we will be implementing linked list through classes classes in C++. So if you don't really have an idea of classes in C++, I would not really recommend you to watch this video. But if you have a little bit idea of classes, functions, methods, uh, all of these things like OOPS concepts, okay, object oriented programming concepts, you need to understand those concepts. Only then you need to come into this video and you will be following my video um, in a better sense. Okay, so let me start this video by telling you what we'll be doing. First of all, we will be implementing a linked list through classes and objects, and after that I'll be making few functions that I'll be implementing. Okay, so if you are very new to this channel, I would urge you to subscribe my video, and if you're looking forward to uh, kind of content in which a person is regularly working and growing, then you are in the right place. Okay, so let me just delete these particular elements so that we are not disturbed. Okay, we're finally here. So the thing over here is, um, I'll so the thing which we need to understand first is, what is a linked list? What is a linked list? So you can understand a linked list as, I would say, a train. Have you ever seen like the different compartments in train, and they are all like connected to each other with a small this particular, in Indian Railway you must have seen like how these different blocks are connected with each other, especially in Indian Railways. Yes. So there are many sections like this, and you can probably understand like this is a whole train, and within the whole train you will have like passenger seats over, like you will have passenger seats in all of these blocks, and at the very first block you will have engine, ENG. Okay, you will have engine and you will have a pilot who is running this train. We'll be having these like setup. Okay, so linked list is pretty much like this. Linked list is let us take passengers as data. Okay, if we take passengers as data, and if we take like what we need in order to make a train. So we need, first of all, if we like understand it in detail, then we can understand that to make a train, first of all, we need a compartment. Okay, second thing we need is a lot of compartments. If we have a lot of compartments together, we can make a train. Okay, and within this compartment, if we look up a single compartment closely, if we look at a single compartment like this, we will always have like passengers sitting over place, and then we will have a tiny space in the compartment of a train. Like this is an empty space. I would like tell I would urge you to think of this particular space as the address of the second compartment. Okay, so here in a linked list, we like this is a linked list. This is finally a linked list, and linked list is two compartments. The linked list has two components. First is your data, and second is your address. So these are the two things which combine together in order to form something which we call as a particular node. Okay, so this particular node consists of data and address, and then the combination of like the accumulation of many nodes together, it can be considered as a linked list, right? So there are different kinds of linked list, and there are different ways to implement linked list. Okay, so at first, now if I try to make a linked list, I have a linked list over here. What we are doing is we have data, and then we have address. We have data and then we have address at every component. Data and address. Okay, data and address. So at last what will happen is that we will be saying that this is the head of the linked list, and at a particular point we'll have to assign null, because if there is no compartment we will have to assign null to tell that our linked list has ended. Okay, so this is the whole structure of linked list, and linked list are of the particular linked list that you are looking at my screen is called a singly linked list. Singly linked list. Okay, and there are other linked lists such as doubly linked list, and circular linked list. Circular linked list. So there are different kind of linked list. If you like need to see a doubly linked list, there is a very uh, easy way to show a doubly linked list, and it is like this. So in a particular singly linked list, like imagine if you are in a train, you're at a particular compartment, and how do you travel inside the train? You, if you're at this point, and you want to go, let's say we name this A B C D. Okay, if you are at compartment number A and you want to go at compartment D, okay, what you will be doing is you will be hopping from this section to this section, A to B, B to C, and then finally C to D. The single constraint that we have, like in this singly linked list, is that we cannot go back. So traversal from a head to this particular element, which is at last we call it tail. Okay, this is called tail. From head to tail you can travel, but you cannot travel vice versa. You cannot travel from tail to head. Okay, it is only possible if a link is there in the opposite direction. So when we add a link at the opposite direction, then we call it, then this particular singly linked list is converted into a doubly linked list, right? When you can go back. So if we have to, like, say our train is actually a doubly linked list. Okay, and the thing here is, for to in order to convert a doubly linked list into a circular linked list, what we'll have to do is we will take our head and we will connect our head pointer to the tail pointer, and then we will take our tail pointer to the head pointer. Like, this is everything, like we are connecting the head and tail within the train, and it will become a circular linked list. So let's go into the implementation of this singly linked list, which we will be learning today. So now guys, we are at the implementation part, and in this implementation part I'll be telling you how to make a linked list first of all, how to make a node, and then we will be implementing certain functions like we will be having few different functions like these. We will be implementing them, and so first of all, let's figure out how we will be making a particular node. The very first thing that we will be implementing is how to make a node. So as I've already told you, like if you imagine a train, you will be imagining certain compartments together, and they are folded by this thread, which is the address thread that I've told you that you need to understand. It has address and then here is data. So address and data are stored within a compartment, and this particular compartment is known as a node. Okay, so this is a not a primitive data type such as int or bool, such like that. It's not a primitive data type. So what we will be doing is we will be taking a help of the object oriented programming in C++ to make a user defined data structure, which will be implemented through class and objects. Okay, and through the help of object oriented programming, we'll be making a node. So how to make a node at first? What we'll be doing is we will be creating a class which can be named as node, and now we will have, as I've already told you, we will have two things in this class. We will have data, and then we will have node pointer next. Now what does this node pointer means? It means that, first of all, okay, so first of all, what this node pointer means, if you have a basic idea about pointers, so pointers are like memory pointers, like what, so what is a pointer? Pointer is something as pointer stores a value's address. So it is a you can say a variable. It is a, like, pointer stores a data very, okay, let me tell you it again. So pointers are such things in C++ which stores, like, the memory address of a particular value. and this particular value has to be the same type, like the data type of this particular value and the pointer should be equal. So if I'm saying that let's say int a equals 5, and now I'm having an integer pointer, let's say p equals a. So if I print like if I print f p, what we will get as an output will be 5. So it will be printing like the address of a somewhere in the memory block. This particular variable is named a, in which 5 value has been uh, initialized, and now there is a particular pointer, and it will be of the same data type, int, because the thing is that since this particular since a will take certain number of bytes, and a pointer should also have that amount of bytes to store it actually. So if I'm having an integer over here, or let's say if I'm having a string over here and I'm having a pointer of integer, it will not work. Okay, so that is why when what we are doing is we are creating a node pointer next. What do we mean by that? Is that first of all you're creating a node in which you have data, and then you are having a pointer which points towards the memory address of another node, and it will also have data and it will also have its pointer. So so this is it. Now I'll be making a constructor of this node. So it's int val. We'll be taking our data and we'll be inserting value into it. And next, since it's a pointer and right now we don't have any value to point towards, we'll be pointing towards null for this case. All I'm trying to say is that now when I will ever call a constructor called node, what we will see is, what we're actually doing is that we will be creating a particular node and we'll be assigning null at the pointer. First we will have data and then we will have address. So this is what we are actually doing over here. Now we also have to make a linked list, right? Since it's a class, it doesn't need parameters. Now we will have a node pointer as head. We'll also have to make constructor. Okay, so we will have int val. No, I guess we will just initialize head. So head will be equal to null ptr. So what we are doing over here is that we are making a linked list in which our head at first, when we are initializing a linked list, our head will always be like, see, if this particular thing is called a linked list, right? If this particular thing is called a linked list, then this particular part is the head of the linked list and this particular part is the tail of the linked list. Now when we will be initializing a linked list, this head part will not be there. So head will be exactly equals to null pointer. Okay, since the data type of head is a pointer, right? So you need to understand it in such a way, like try to understand it. So this particular part, we have called this particular memory location as head, and it is of data type node pointer. Okay, so what does it mean is that it will contain the address of a particular node, right? So this particular part will store this node's value. Okay, and if we have a tail as a particular node pointer, we can point it towards the tail of the linked list. And we are like defining it because if we don't have head of a linked list, we cannot travel through the linked list. Okay, if we don't have tail of the linked list, we will never know when the linked list is ending. But it is not necessary to make a tail of a linked list, but it is very necessary to make a head of the linked list. Like we will need to have a particular point from where we are starting, right? And now I guess it's time to make these particular functions that I've already mentioned. Let's say insert at head. So if I am saying I'm inserting at head, insert at head, we'll be taking a particular value and we want this value to be inserted at head. So what we are actually doing when we are inserting at head is very simple. We'll be taking a linked list. We'll be taking a particular linked list like this. We already have a particular linked list and we want to add something at the very start of the linked list. So we want to add a particular node here. So what changes do we think that we are doing? At first, our head will be at the very first node of this particular linked list, and then all we have to do is we need to make a particular node and we have to assign its address to the very first node in the linked list. And the second thing that we'll be doing is we will be changing our head. We'll be changing our head from the first node to the node that we have attached at the beginning. And now when we will be looking at the changes, we will have something like this node that we have added. Now this is the earlier head node which was changed over here. So if we just do these two few processes, we will be able to add a particular element at the head of this linked list. Okay, so first of all we need to make a node, and the node will be made like this: new node. We will be using a new pointer node, right? And value over here. Okay, now when we have made our node, we will say new node. Next we will add it to head of the linked list, and then head will be equals to new node, and then we will just return because our data type is void. Now there is a certain thing like which we would say edge case. If our head is exactly equals to null pointer, what if that's the case? Then we'll be just making our new node, and hmm, so if our head is exactly equals to null, then we will be making this particular new node and we will be assigning it as the head. I think, yeah, then head will be equals to your new node, then return from this point. Okay, so what I'm trying to do is, if our linked list is empty, let's say if there is, the head is pointing towards null. Okay, so if our head is pointing towards null, that means the linked list is not created. Then what we are doing is we are creating a node in which we have initialize the value as, let's say, 5, and the address of this linked list, because when a node is created, its next is always as null. We just have to take a high head pointer and we will place it here, and that's it. This will be the first node of the linked list. Okay. I think this is fine. Now we'll be moving on to our second function, which is insert at. Okay, so insert at head and insert at beginning are the same. Void. Now we'll be inserting at tail. Insert at tail. Okay, so we want to insert our value in val at the very end of the linked list. So first of all, if head is null, if head is null, what we will be doing is, we'll be, as usual, we will create a node, node, okay, and what we will do is, if we are at, if our head is null, we will say head equals to new node, and then we will just return. We will do the same thing that we did over here. Okay, but from after this we have to change something. So this requires traversal of a linked list too. When we want to add something at the very end of the linked list, then we will, when we want to add something at the very end of the linked list, then we will have to traverse throughout the linked list, and we will have to go at the very last node. Okay, let's say if a linked list contains these four nodes, okay, and at the end it has value as null. Now we want to add a particular node at this point. Okay, we want a particular node over here. This is what we want to add. So what we will be doing is, since we will be knowing our head pointer, through the help of head pointer we can reach over here. We will have a temp, okay, and this we will have a pointer as temp, and we will be going through temp, like we will be increasing temp's value until until we reach a point where a particular temp, with a particular if it is pointing towards this node, then if this node's particular next is equals to null, that means we are at the end. So if, like, look at the every last node in a linked list, it will have its next assigned to as null, and we want to reach to that point. We will take our temp and we will reach to the node whose next is null. If a particular node's next value is null, then we will add the node that we have created. What we will be doing over here, now let's just draw this particular thing again. Okay, so what we will be doing over here is, if this particular value, if this is the last node, let's say, now its next is null. Okay, its next is null. What we want is to add this particular node to the linked list at the very last. Its next will always be null, as we have defined in the class node. Now all we have to do is, we have to take this address and we have to point it towards the node that we have created. Okay, so it will be pointing towards the new node, and this is all that we would be doing at insert at tail. So fine, this is it. If I want to add, like, I'll have to say node temp equals to head Now our temp is at head. Now we will be traversing throughout the linked list, and we will be doing so like until temps next is equal to null. Temps, what am I doing? Temps next should not be equal to null. If temps next is not equal to null, then we will be moving forward and forward. Okay, if I try to like visualize this, let's say we are here. Yeah, let's say we are over here. Now since our temp is over here, and temps is holding the value of this particular node, and the next of this node is any other particular node, it's not null. So if it is not null, we will move our temp towards the next node, and similarly we don't have the next node as null, we will move our temp over here, and at last we'll be taking this while loop till the termination condition is that if a particular node's next is null. Now, when a particular node's next is null, that means it's the last node and we need to stop it here. The second thing that we'll be doing is we'll be taking our new node, and like temps next we will be assigned to the new node that we have already created, and since its next value will always be null, that is how our like element will be added at the last. Okay, so temp equals temps next. Because we are working with addresses, we have to go through the linked list like this. And now when we have reached the end, so if you have reached the end, what we will be doing is we will be saying temps next will be updated to new node. And I guess that's it. If our particular head is null, we will be doing this, and if our linked list is having some particular value, we will be traversing at the very last of the linked list, and then we will be adding temps next to new node, and then we just need to return. Okay, now we have inserted at head, we have inserted at tail. Now the other function that I have to make is delete a particular node. Okay, so if we want to delete a particular node, and how we will be deleting a particular node is by value. Okay, so let's say if you're given a linked list like this, if you are given a linked list 5 4 3 2 1. Okay, and we want to like delete a node uh, whose value is 1, like whose value is 3. Okay, so delete node at 3 whose value is 3. So again, like we will be traversing, and I've already told you how to traverse throughout the linked list. We'll be taking temp which will be initialized to the head of the linked list, and then we will be checking at every point, is temp's value equal to 3? No, if it's not the case, so we will move ahead. Okay, is temps value equal to 3? No, that's not the case, so we will move ahead. Is temps value equal to 3? Yes, temps value is equals to 3. Now how we will be deleting this particular node? Okay, to delete this particular node, what we will be doing is we will be just playing with the pointers. We will take, okay, so this is actually not how we will be doing it. I'm so sorry. uh, But the thing over here is that we will check temps next. if it is equals to 3, right? Because we are doing this because we don't, like, we cannot go back if we are at temp. If temp is at 3, we cannot go back, and we cannot like manipulate all of these links, because yes, we are already past the point from where we can manipulate. So what we will be doing is we will be going towards this point. Okay, we will be going to previous of temp node. Okay, so if temps next is exactly equals to 3, which is this case it is true, what we will be doing is we will be taking this temps value, and we will be we will be like taking this pointer, and we will be pointing it towards temp, like next next we will be moving 2 steps ahead. Okay, and then all we need to do is delete this particular node. Okay, this node will be deleted. Why we are not going to temp and deleting the value? If we are at temp and we are deleting this value, the whole linked list will be broken down. Like if we delete this value, now this temps previous will not have any idea where it is pointing towards, because that pointer has been deleted. And temps next will have like no element previous to it. That is why we want our temp to be at temps previous, so that we can just manipulate all of these links. And the second condition, let's say if a particular node is not there in a linked list, what will happen is that move we will move okay, if a particular value is not there, we will move over here at temp, and temps next is equals to null over at this point. So when this happens, we can say that this particular node doesn't exist. Okay, so that's all. So we will be having two termination conditions for this while loop. The very first condition will be if temps next is exactly equals to the value that we want to delete, and the second condition will be if our temps next is exactly equals to null, then we will be terminating the linked list. Okay, so a particular value will be given to us, and so first of all, we will be saying if head is exactly equals to val, if head's value is exactly equals to val. Okay, so if head what we will be doing at this point, if the very first node of the linked list is to be deleted, then head, then what we will be doing is I can write this over here. Then we can say that head equals to temps next, right? And we can say delete temp and then return. Okay, or if we have an empty linked list, if our linked list is empty. Okay, so if a linked list is empty, what we will be doing is we'll just be returning, because there is no value to be deleted. Okay, and if none of these cases are true, like we don't want to delete the head of the linked list, or our linked list is not empty, then what we will have to do is we will have to traverse till value equals target, like a target to be deleted was 3 in the earlier case where I was telling you we want to delete 3, so 3 is our particular target. Okay, so temp is already initialized to head, and while temps next is not equal to value and temps next is not equal to no. Like we are not at the very last node. Okay, what we'll be doing is temp equals temps next, and when we are at the very, like, we will either have two conditions. Either we got the target, okay, either we will be here at the previous node of 3, we would be here, or we would be at the very last of the linked list when this particular while loop ends. So we will need to make two conditions. If we are at the last node, okay, then we will just need to check its value, and we will say if this value is not, no, we don't really need to check, because if we were here it's temps next value, if it is the, if it is equals to val, but it is not equals to val, that's why we are at the at this node. And now temps next is null, that means we have already checked for the last node's value. We can just return that the target doesn't exist. Okay, it doesn't exist within this linked list if we are at the last. If temps next is exactly equals to null, we'll just need to return. Okay, see out target does doesn't exist. Okay, and then we'll just return. But if the target exists and we're somewhere there, okay, if target exists, like 3 exists, then what we will be doing is we will be taking our temps next equals, okay, so if it exists, then temps, then at the this pointer value, which is temps next, will be storing temps next. Okay, so we'll be storing like temp के next में क्या आएगा, temp के next का next आ जाएगा. ठीक है, तो आप दो स्टेप आगे बढ़ चुके हो यहाँ पर से. Now you are 2 steps ahead. Now we have changed this link towards here. What else we need to do is we need to temp equals, maybe I can have another node which is cut node, which will delete the value. It will be temps next, right? What I'm trying to do is I want this particular target to be as CUT. This is another node pointer that we'll be using, and this node pointer will point towards temps next. Okay, and then we just need to delete this particular node, and finally we will return. Okay, now I guess the very last function is left, which is display function. So display function will not have any parameters. It will just display all the elements if all these elements exist in the linked list. So we'll have a particular edge case as if head is exactly equals to null. Yeah. Okay, wait a minute. So if head is exactly equals to null, then we will return. Okay, no elements in the linked list. I think I will have to provide nodes pointer head address of this particular pointer. I guess if I'm right. Okay. Now if there are elements within the linked list, then what we'll be doing is node pointer temp equals to head, or we can simply have a node which will carry heads value, and then while temp is valid, while temp is not null. Okay, so if temp is valid, what we'll be doing is cout temps data. Okay, and to show the link we can obviously have this, and at the very last, when we have nothing in the linked list, we can just cout as null, right? And then all we need to do is return from this point. Okay, so this is fine. Now our code is at the very what do we call, now our code is at the last point. We just need to initialize everything, and we need to use all of these functions. Now I will kind of use all of these functions. Okay, so let's do it. So before doing this, let's just check temp will be equals to temp next. We are creating a list which is of data type linked list, and we can access methods of this. Let's say insert at head, I can have 1 2 3 4 5. Okay, let me just run this code. It's showing that there are errors within my code. Two problems with this file. Load iostream. So the thing was that my compiler wasn't working correctly. I installed my like C++ compiler yesterday, and it was not working. So I fixed the problem. Now here we are. We can definitely see a lot of problems over here, and let's just tackle these problems. First of all, where I'm first problem. Okay, g++ dot cpp. Okay, so there are a lot of problems. First of all, this has no pointer type node. First of all, when I'm like accessing next or data, there is a problem. Okay, so these are all private member functions. Let's just take them as public member functions, because then they can be accessed throughout the code. Okay, let's try to okay So there are some problems. Let me just figure it out first. New keywords not okay. So I have to create a pointer, right? It's fine over here. Again, I need to create a node pointer. Okay, we are working with pointers every time. Yes. So now errors are like significantly less. Temps next should not be equal to val. Let's see what other errors are here. Okay, now my screen isn't like completely filled. Mm, at line 25. Okay, here is some issue. You can obviously take pointer and first error is here and then second error is here. Okay, now there is only one error. It's about value. Hmm, well, I'd already defined val over here. Okay, so it's temps next is an address, but I want to access its data. Like temps next data. That's what I want to do. Okay, now it's fine. Okay, got it. A.exe. We are on Windows, guys. So it's working fine, I guess. 54321. 54321. Inserted head. Yes, because I'm inserting at head. First of all, head was 1, and then it became 2, it became 3, it became 4, and it became 5. So this was like this. I've right now I just used two functions, which was inserted head and insert and display function. Okay, how many of the functions are left? Display function and insert at tail. So let's first of all insert a few values at tail. List dot delete. Let's just delete few values, or insert list dot insert at tail. Okay, if you're inserting a certain value at tail, let's say I'm inserting 10, and this dot display. Let's see what happens. Now here are some problems. Okay, I just need to comment it out. Mm, okay, okay. After this, after this display, or after null, I can do something as null. Now we'll have a better output. Okay, so as you can see, first of all my linked list was 54321, and then I entered an element at the very last or at the tail. So our function, which takes input and adds it at the end of linked list is working fine. Okay, so inserted head is working, inserted tail is working. Now all I need to do is comment it out and delete a particular node. Let's say I want to delete a node with a value 3, and then I want to store delete node at value 10, like the last node. Okay, what if it's like this? Hmm, I'm not displaying it, so just dot display. Now it will work. So yes guys, I'll just make it more clear. So as you can see in the terminal, the first display function, uh, we were inserting few values, and then for the second display function we inserted something at tail, and then for the third display function I deleted two values with 3 and 10 in the linked list. And as you can see the list, particularly here at the very last line, you can see that 3 and 10 are not there in the list. So this is all guys for today's implementation. I hope you like it, and I hope you understood whatever I was doing. So thank you guys. That's